Welcome back. My name is Jesse Helms with Intermountain 3D, and this is the final step in the reverse engineering process for the Turbo Air part. In this process, we're actually printing the part from the CAD data that we created, which was created from the scan data and mesh data that we achieved. So at this point, we have actually created an STL file from the CAD data. We've loaded it into this machine. This machine is a 3D Systems ProJet 6000 with an HD head on it, very high definition laser. The SLA process works with a vat of liquid resin, and that resin is solidified with a UV laser. So wherever you see that blue light is the actual UV laser, and it's actually producing a cross section of the part, because this part in the system has been sliced into hundreds, thousands of layers, sometimes depending on the height. And it is actually creating a cross section with that laser. And wherever that laser hits, that material is solidified. And right now what's happening is there's a blade that goes across the material. It's called a recoater blade that just coats extra material on top of that solidified material. And this tray is actually lowering layer by layer, and it's going to ultimately create the full part. And once the part's completed, and you can see the tray is down a little bit further down than before, it's now starting to raise, and you'll actually see the part raising out of the resin. The part is completely solidified. It is a clear polycarbonate-like material, so it is fairly rigid. It's got good clarity properties, but it's a real nice material. It's very accurate to print on this machine and gives you a good quality part. Now, the next step, we have to post-process this part. So after we pull it out of the machine, we have to actually pull it off the tray and essentially get off all the residual resin. So this part is actually created with little stanchions, little support systems under the part that break off, and you can kind of see it still stuck to the tray, and the part comes off. We're just going to rinse it off with a little bit of alcohol here, and to just get off all that excess resin. And then ultimately we're going to do a final cure in a UV system, because again, this material is all cured by UV light. So again, we're just washing off that extra resin, and you can see the part. It's completely translucent, clear, but it's an accurate representation of the CAD data. So next step is we're going to stick it in the UV chamber. So we have a high intensity UV chamber that we'll put it in, and it's got a rotational table. We'll just put it in there for 10-15 minutes, depending on how long. The length depends on the size of the part, but we'll essentially hit go, and the part will cure for a little bit, and it will just make sure that the outer layer is completely solidified and hardened. So now the part is complete. You can see it comes out of the tray, and we have a final part that can be test fitted for the user. Now you can see the part in comparison to the original part. The original part, again, very worn, beat up parts, chunks missing out of it, bent up, but you can see the quality of the part next to the original part. Very accurate. The part was ultimately a good fit, so the customer took the original part, we scanned the data, we were able to create a CAD model of the part, then from the CAD model we were able to print in a high definition laser SLA machine. We were able to print an accurate part for test fit, and once that was verified, we were able to actually have it printed in a production grade nylon part that is ultimately an end user part. So we have many different materials that we can source and print in, depending on the customer's ultimate need. So thank you for watching this video series, and we will be coming back with more. Thank you very much.